say this motion is uniformly accelerated motion. Uniformly accelerated motion. Now what about average acceleration? Delta V by delta T. So for this we need 2 points. Let me take, these are two times between T1 and T2. Let me calculate average acceleration, that is delta V by delta T. It gives the slope of line joining these 2 points. It is same as this is straight line slope. That means average acceleration between any 2 times is the same as instantaneous acceleration at each and every instant of time. That means for uniform motion, instantaneous acceleration is same as average acceleration. So I say just acceleration is constant. So a bar is constant. So its magnitude and direction is constant. So uniformly accelerated motion. Here uniform motion for this. Uniform motion means velocity is constant, velocity vector is constant. Uniformly accelerated motion, we specify accelerated. So acceleration is constant. Now what you can understand from this? Here its initial velocity is not equal to 0. Say t at time t equal to 0, velocity is not 0 because it is intersecting velocity axis at particular point. So it has some velocity value here. That's why initial velocity is not equal to 0. Now let us talk about instantaneous acceleration. You take this point at this time. Let me draw a tangent. Slope of tangent drawn at particular time gives you instantaneous acceleration at that point, and here also instantaneous acceleration at this time. And this instantaneous acceleration is not same, and the angle made by this tangent with the time axis increases. That's why acceleration value also increases here. What we can understand. Next, let me talk about average acceleration. So you have to select 2 points between this time and this time. I have to calculate average acceleration. So this, it is equal to slope of line joining these 2 points. This is for T1 and this is for T2. And if you select these 2 points and slope of this line, straight line, gives you average acceleration between these 2 times. That means average acceleration between any 2 times is not same as, may not same as average acceleration between any other 2 points, or may equal even, may or may not equal. Suppose if you select these points so that you are getting some line which is parallel to this, yes, you will be getting average acceleration is same. And one more thing, this average acceleration may not be same as this instantaneous acceleration, or may be same. Sometimes if you select a suitable point, if you draw a tangent, slope of tangent from VT graph gives you instantaneous acceleration, and it may be equal to, it may be parallel to this line. That means average acceleration between these 2 points is same as instantaneous acceleration at this point. So this is what conclusion is. Now this velocity time graph, here what happens? Time only increases, there is no decrement of time. So here this is the graph, velocity value gradually increases. What we can understand? Velocity value gradually increasing, and slope of this tangent decreases. Slope of this tangent decreases means slope of tangent gives you acceleration. So acceleration value decreases, what we can understand up to here. But from here to here, what happens? Again time is decreasing. Time up to here increases, again it has to decrease. So it is not possible. That's why this graph is not at all possible. This is one reason, and another reason is at particular time it may have only one velocity, but here 2 velocities are possible. Is it correct? No, at particular time attaining 2 velocities by any particular body is not possible. For these 2 reasons, you can say any reason, but finally we have to conclude that this graph is not possible. That's all. Next, from the same reasons, so time here up to here increasing, uniform speed with uniform speed. Next, again here again time has to decrease, so there is no decrement. This is one reason. Or at one particular time 2 positions. Is it possible? Is it possible for you to be at the same time in the class and in cinema theater? It is not possible. So 2 positions attaining at the same time is not possible. That's why this graph is also not possible. And when it comes to here, speed time graph, here speed is a scalar quantity and we have studied that it has only magnitude. So only vector means it has both magnitude and direction. As far as the direction is concerned, for 1D motion, what I told you, you can take if the vector is along positive axis plus negative axis minus. Okay, but speed is a scalar quantity, it does not have any direction. So we don't assign any positive value or any negative value for that speed. So everything is magnitude, that is positive value only. But here, as far as the graph from here to here is concerned, so it takes a negative speed. So it is not possible. It is not possible. That's why this graph is also not possible. And one more thing here, time. Suppose if you draw the graph like this from here to here, time actually counting time we take it as 0. So most of the cases we don't consider time negative, but to describe the situation, that is just before that what happened, I want to talk about that situation. So my problem starts from 10 o'clock onwards, but I want to talk about what happened just before 10 o'clock. In that cases, there is a chance to take time is less than 0, what happened, then you can describe that. Means time negative is not possible once countdown starts, but whenever I want to talk about what happened just before that situation, then sometimes we can take when t is less than 0, this is the thing what happened. So time may be, but speed will never be negative. And as far as time is concerned, not a physical situation, as far as concept is concerned, if you want to talk about any situation, then under that condition only we just allow ourselves for t is less than 0 only to understand the situation what happened before the time that we start counting. But speed is a scalar quantity, it will never be negative.